Good morning, student. In today's session, we are going to cover the most repeated conversion of class 12 CBSE, and this question comprises of 5 marks. So these are the conversion which you will be able to do after this session. So whenever you are going to convert any hydrocarbons to aldehyde or carboxylic acid, you need oxidizing agent. So any hydrocarbons on conversion with the mild oxidizing agent will get converted to the alcohol. If it is a primary alcohol, on further oxidation it will give you aldehyde, and if it is secondary alcohol, on oxidation it will give you ketones. They both, aldehyde and ketone, on further oxidation will give you carboxylic acid, and carboxylic acid on oxidation will give you carbon dioxide and water. The same thing can be reversed back by using any reducer. Any alkyl halide, when you are treating with alcoholic KOH, it is going to remove hydrogen and HCl from the solution, and it is going to make the alkene. On further treatment with any halides, it will get converted to the alkyl halides with a single bond. Now on further treatment with alcoholic KOH, it will again remove KBr from that solution and will convert into the triple bond. And if you want to double the size of your hydrocarbons, you can use the Watts reaction. So if you take any RCH2CH2Cl and add the same amount of component to it, they both get combined together in presence of dry ether and sodium. So this is a Watts reaction. You can just double the component of hydrocarbons. Like ethane can be converted to the butane, propane can be converted to the hexane. So you can just double the amount of hydrocarbons, number of carbon atom in it. When you are treating with the aqueous KOH, aqueous has got a large amount of water in it, so the OH ion will get added to the hydrocarbons, and you are going to get the alcohol in it, right? Which on further oxidation will give you aldehyde, and aldehyde on further oxidation will give you carboxylic acid. If you are using strong oxidizing agent like KMnO4, it will directly convert alcohol to the carboxylic acid. And for the formation of the amine, you can use ammonia. Now, with the use of Grignard reagent, you can convert any alkyl halide to the primary, secondary or tertiary alcohol. So, Grignard reagent, when on further treated with the formaldehyde, it will get converted to the primary alcohol. If other than any formaldehyde, you are using any aldehyde, whether it's ethanol, propanol, butanol, it will get converted to the secondary alcohol. And if you are using ketone agent, your tertiary alcohol will be the product. And if you want to get carboxylic acid from the alkyl halide, you can also use carbon dioxide directly to get converted into the carboxylic acid. Next is the conversion of aryl halide. Here we are taking chlorobenzene. Chlorobenzene, when treated with the sodium hydroxide, it will get to change to the sodium phenoxide, which on treatment with dilute hydrochloric acid will get converted to the phenol. So this question is repeated many times, the conversion of aryl halide to anisoles. Next, chlorobenzene is treated with the Cl2, it will get converted to orthodichlorobenzene and paradichlorobenzene. In this, the paradichlorobenzene will be the major product and orthodichlorobenzene will be the minor product. Next is the conversion when we are taking aryl halide with the chloroform in presence of sodium, it will give rise to the toluene. This is also repeated many times. Toluene, when further treated with chlorine in presence of any Lewis acid, it can be FeCl3, it can be AlCl3, it will get converted to orthochlorotoluene and parachlorotoluene. And how to convert aryl halide to benzene? We just treated it with the hydrogen atom, that is hydrogenation in presence of nickel. Further, aryl halide, when treated with sodium in presence of ether, it will get converted into diphenyl. Remember Watts reaction, in that we are using that to double the amount of aliphatic hydrocarbon. Similarly, the phytic reaction is used for the conversion of doubling the amount of aryl compound. There is one more reaction, that is Watts phytic reaction, which includes when you are taking one aliphatic hydrocarbons and one aromatic hydrocarbons, they both are combined together. So that is called as a Watts phytic reaction. And if you are taking both the aryl group, then that is a phytic reactions. Next is the conversion when we are taking the chlorobenzene in presence of concentrated H2SO4, and the reaction is called as a sulfonization. Similarly, the same reaction can be used for the nitration of the reaction, where you are using concentrated nitric acid for that conversion. So in place of SO3H, there will be the nitric acid will get attached to it. Next is the conversion of alcohol. Alcohol when treated with concentrated H2SO4 will get converted to alkene. Remember we have done in the first slide that it is going to dehydrate the things. So OH from this carbon atom and H from this carbon atom will get removed and it will convert to the alkene, that is double bond, which on hydrogenation in presence of nickel, you can take platinum or platinum, any compound, it will give converted to the alkene. But if you are treating that alkene with the bromine or any halide, so it will get converted into alkyl halides, which on treatment with alcoholic KOH will remove HBr and will change it to the triple bond, that is alkyne. So this is the conversion where you can convert an alcohol to alkene and then to alkane and then to alkyne. If you are taking concentrated H2SO4, it is going to dehydrate, that is water molecules will get removed, and if you are using alcoholic KOH, it is going to remove hydrogen bromide from the reaction. Further, alcohol when treated with a mild oxidizing agent, that is copper, in presence of large amount of heat will get converted to the aldehyde, which on further treatment with alcoholic KMNO4 or K2Cr2O7, where it has got a large number of oxygen in it, will get oxidized to the carboxylic acid. So KMNO4 is a strong oxidizing agent. You can directly convert an alcohol to an acid. Now there are the few conversions related to the phenol. Phenol when treated with zinc will change to the benzene ring. This is again an important conversion. Next reaction is acylation reaction, that is the Friedan-Kraft acylation reaction. Here the phenol is treated with H3COCl, that is acyl chloride. In presence of Lewis acid, it will get converted to the ortho and para phenyl acetate. Phenol when treated with the bromine, in presence of CS2, only one bromine will get added to the phenol compound, but when we are treating with the Br2, in absence of carbon disulfide, the bromine, 3 bromines will get attached to the ortho para position. 2,4,6 tribromophenol will be formed. Phenol when treated with the concentrated H2SO4 and HNO3 will give to the 2,4,6 trinitrophenol, which is also called as the picric acid. Again, this one is an important conversion repeated many times. Next reaction is called as Golgi reactions, in which the phenol is treated with NaOH and CO2. It will form salicylic acid. Salicylic acid on further treatment with concentrated H2SO4 and an anhydride, it will give rise to the aspirin and CS3COH. Again, important reactions, the formation of aspirin with the help of alcohol. Alcohol when treated with chloroform, NaOH and dilute H2SO4, it's form the salicylaldehyde, which is called as the Riemer-Tiemer reaction. Again, the formation of salicylic acid with the help of the Riemer-Tiemer reaction. Only difference is that in presence of chloroform, we use CCl4. CCl4, NaOH and HCl, in terms of any acid, HCl, H2SO4, you can use any of the acid. It will form salicylic acid. This reaction is called as the Riemer-Tiemer reaction. Phenol when undergo hydrogenation in presence of nickel, palladium or platinum, it will form cyclohexanol. Again, this is an important conversion of converting phenol to a cyclocompound. Phenol when treated with diazonium salt in presence of sodium hydroxide will give you para-hydroxyazobenzene. Why we are calling it a para-hydroxide? Para position, it's hydroxide group, and azo is nitrogen, benzene is these two compounds. So that is why it is called as a para-hydroxyazobenzene. Next is the conversion of aldehyde. Treated with zinc amalgam plus HCl, it will give rise to an alkane. This reaction is called as a Clemmensen reaction. Another conversion of aldehyde to an alkane is called as a Wolff-Kirschner reaction. Only thing is that we use NH2 here in presence of KOH and glycol. First, it will get converted to the hydrazone, which on further treatment will give you an alkane. This reaction is called as a Wolff-Kirschner reaction. So conversion of aldehyde to an alkane can be done by the Clemmensen reduction reaction and Wolff-Kirschner reaction. These two reactions are important because they are mostly related to each other. Only thing is that they are and the products are same, only the reagent is different in both the case. In Clemmensen reaction is zinc amalgam plus HCl, whereas in case of Wolff-Kirschner reaction, it's NH2 in presence of KOH and glycol. Aldehyde, when undergo hydrogenation in presence of nickel, will give rise to the alcohol. Alcohol on further treatment with H2SO4 will remove water molecules from it and will give alkene, which on bromination will give you hydrobromide, and further on treatment with alcoholic KOH, it will give you alkyne. But if alcohol when treated with PCl5, it will form alkyl halide. Alkyl halide on further treatment with ammonia will give rise to the alkyl amine. But if you treat aldehyde with KMnO4, you will get an acid, that is carboxylic acid. Remember, the number of carbon atoms remains same in this case. With this, we come to an end of this session, and we have covered almost all the conversion of class 12th. All the very best for your exams on 27th. Do well. Thank you. God bless you.